Hello, this is a lesson on how you prove that something is a cyclic quad. You get this question in your exam where they say prove that ABCD is a cyclic quad. So there are actually 3 ways that you can prove. You can use one of them. The first one, if one pair of the opposite angles of a cyclic quad of a quadrilateral are supplementary. What it means here is that you are not going to have a circle around that. You're just going to have a quadrilateral. Now, if you can prove that the opposite pairs add up to 180, then that thing is a cyclic quad. The second one, if you can prove that the exterior angle of a quadrilateral that doesn't have a circle is equal to the opposite interior angle, then that thing will be a cyclic quad. And then the third one is the one that we're going to use example for. If a line subtend equal angles at 2 different points on the same side of the line, then the 4 points are cyclic. This is the example that we're going to use, is the third one. Let's look at an example. Now, you remember that usually in a question paper, you get a circle and then you get a quadrilateral inside. So these kind of questions, you don't have a circle. You are supposed to prove that this thing is a cyclic quad. So you see here, we have this line AB and we have these angles A and B. If you can prove that angle A and B, they're equal, then this whole thing will be a cyclic quad. Let's see if you can do that. When you look at this triangle MBC, we have an exterior angle, and the theorem says the exterior angle 72 degrees is equals to the sum of the interior angle. So it's equals to 32 plus B. Oh no, B doesn't have a degrees. B has this angle. So if I take the B to the other side, I'll get 72 minus 32 is equals to B. Oh, I've missed the reason here. You lose marks if you do that. The reason is exterior angles of triangle. And then B, 72 minus B, it should be 40 degrees. It means B is 40 degrees. Okay? When you go to a diagram, use your pencil and write 40 degrees B. Okay, what do you notice there? We can see that angle A is equals to angle B is equals to 40 degrees. Okay, so it means that A, B, C, D is a cyclic quad. Why would it be a cyclic quad? Angles on same segment are equal. Because these angles that are subtended by this line are equal, then the whole thing is a cyclic quad. Let's look at another example. In this question also, you're asked to prove that ABCD is a cyclic quad. So I think you need to prove that C plus A is equals to 180. Okay, let's see if you can find A. Do you see here you have lines that are equal? It means A, D, B, this angle here is equals to 35 degrees, is equals to that angle there. And the reason is angles opposite equal sides. Okay, so you have a 35 degrees there. You come with your pencil, you write it in like that. And then A is equals to 180 minus 70. 35 plus 35 plus A will give you 180, some angles of a triangle. So I've already added them and took this one. Some angles of triangle. So it means your A is equals to 110, right? So do you see that A plus C, angle A plus angle C is equals to, angle A is 110, angle C is equals to 70, the total is 180. So you can say, therefore, A, B, C, D is a cyclic quad. Why do you say it's a cyclic quad? Your reason will be opposite angles of a quad are supplementary. Or you can say, if your English is as bad as mine, you can say add up to 180. This is what supplementary means, is that they add up to 180. The opposite angle, that angle, and that angle, they add up to 280. Therefore, the whole shape is a cyclic quad. So you need just to practice. This question will be within a question. There will be drawings and other things. You have to look at that and then find the proof that they are asking you. Thank you for watching. This is the end of our lesson.